Hi, welcome to question number 5. This will be the last video for tutorial week 4. As usual, the solutions to this problem can be found in UTS Online. However, I'll encourage all students to try this problem on their own. I'll firstly create a new worksheet, and in this problem, I will copy and paste or replicate the data found in the tutorial handout and hit here. So my first column will be time in years, and we'll have a cash flow that's occurring at a particular year. Our years from year 0, which means the cash flow is happening today, and we'll do this until year 8. Our cash flow for year 0 will be minus 80,000. The minus sign indicates that this is an expenditure. We are spending $80,000 today. The cash flow for year 1 will be 14,000, and this represents an income. We expect to receive 14,000 after 1 year has elapsed. The cash flows for 2 to year 8 are also 14,000 per year. So I'll just copy and paste this to the other cells, and I'll change the style of the numbers by changing it to the currency style. The currency style adds a $ before the number, and it separates the numbers by commas by every thousands. So the numbers are grouped by thousands. These cash flows are future projected cash flows, and more commonly this is known as the future value. So this is the future value of a cash flow happening in year 0. This is the future value of a cash flow that's happening in year 1, so on. The first problem requires us to graph these cash flows using a simple chart. So to do this, I'll highlight these numbers, including the words cash flow. I'll click Insert, and I'll choose a simple 2D column chart. Now, we're not quite ready. You can see that the numbers along the horizontal axis start with 1, 2, 3, 4, 5, 6, and this does not match our original data where our time starts with year 0. We'll need to make some data. Right-click the graph, choose Select Data, and I'll change the horizontal axis labels to contain our actual labels that start from year 0. So I'll select this, click OK, and click OK to confirm this change. And here's our graph. Here's a graph containing the cash flows from year 0 to year 8. I'll put this graph aside because it's not needed for the other questions. For part 2, we'll need to compute the present value of these cash flows assuming an interest rate of 5%. I'll add this interest rate below. So R will have a value of 5%. And in order to calculate the net present value of these future cash flows, we would need to calculate the present value of each individual year. There are a few ways to do this. I'll firstly use an Excel formula known as PREV, and it returns the present value of an investment. So in other words, it calculates the amount that a future payment is worth now. PV will contain 4 parameters. The first parameter will be rate, and this is our interest rate, which is 5%. I'll press F4 in order to make this reference an absolute reference. NPER refers to the number of periods. In other words, the number of years. This would be year 0, so this cash flow is happening today. The next parameter, PMT, will be 0, as we're not expecting a periodic repayments for a particular or for a single cash flow. And lastly, FV will be the future value. When I press enter, it gives us a present value of 80,000. This is not quite correct. This present value is plus 80,000, while our future value is minus 80,000. We want to keep the signs the same. So in order to keep the sign the same, we'll add a minus b to here, which would flip the positive 80,000 number to minus 80,000. Okay, this appears to be correct. The future value and present value are the same value because this is a cash flow that's happening today. So here are our present values for year 1, year 2, all the way to year 8. We can also calculate the present value using a formula that is given in the lecture notes. To do this, we'll just need to discount future value against this term. So we'll divide B2 with plus the interest rate, keeping this reference fixed to the power of 0, or to the power of the number of years. So this is minus 80,000. I can copy and paste this to the other cells, and the numbers, as you can see, are exactly the same. So these two different formulas give us the same result. Now, the net present value will be the sum of all present values listed here. So this will be sum, and I'll highlight these cells to indicate our range. And this will be $10,484. That will be the net present value of these projected cash flows, assuming an interest rate of 5%. For the last problem, we wish to calculate the IRR, the internal rate of return. The internal rate of return is the interest rate that makes the net present value of this projected cash flow equal to 0. And we can solve this problem easily by using the solver tool. I'll click data, I'll click solver, and our objective in this problem is to set the net present value to 0. And we do this by changing the interest rate. When we click solve, we should see an interest rate of 8%. And this is our internal rate of return of this projected series of cash flows. So 8% is final result. And to see if we are on the right track, let's just make a few changes to our original numbers. If I were to change 14,000 to, let's say, 20,000 and change to 50K, 50K, and 50K, and 50K, this should result in a larger internal rate of return. So I'll click solve again. I would set the objective cell C11 to a value of 0, and I'll change cell C12. I'll click solve, and this new series of cash flows results in a much higher IRR. So IRR is a very useful way to evaluate the profitability of an investment. And we can see that when I increase the cash flows in future years to a larger number, our IRR has increased. I hope you have enjoyed these videos, and I look forward to seeing you soon. Thanks.